One thing you often want to do is interpret a p-value, which is sort of the end result you get from a hypothesis test. So the general phrasing is something like, if the null hypothesis is true, there is a p-value % chance of observing the results we observed. But this is the generic version. You don't want to answer a question like that. You always want to put it in context. So just replace the null hypothesis is true with whatever the null hypothesis is in this situation. Same with your exact value of the p-value. And the results we observe turn that into the actual situation. For example, a new robot is capable of making 80% of welds correctly. But you think yours is broken, though. So out of 256 attempts, it made 197 correctly. So you set up your hypotheses here. Your null hypothesis is p equals 0.80 right from here. The alternate hypothesis is p is less than 0.80. Because you think yours is broken, if it's broken, it usually works less well, so fewer than 80% of welds will be made correctly. Go through the calculations. P hat is 197 over 256, which gives you just about 77%. The standard deviation of p hat, because of the numbers I used, works out evenly to 2.5%. Calculate the z-score, p hat minus p, divided by that standard deviation. You get negative 1.219, which, using your normal model calculation, like GeoGebra or something, gives you a p-value of just around 11%. So then the question asks you to interpret the p-value. Start off with this sentence. If your pen doesn't work, grab a new pen. So if the null hypothesis is true, if the robot makes 80% of welds correctly, is this part, there is an 11.1% chance of observing the results we observed would be observing 197 or fewer correct welds in 256 attempts. So here I phrase it in terms of the number of successful welds, but you could also phrase it in terms of the percentage. So you could replace this part with the percentage chance. So instead of the part in the red brackets here, you could replace that with 77% or less. That's supposed to say successful welds in 256 attempts. So you notice that the interpretation is a conditional statement. You have to write a little bit because you're assuming the whole time the null hypothesis is true. You can't leave that part out. You can't leave that part out. You can't leave out the p-value. You need to include all of this to have a successful interpretation, which makes it a difficult concept because it is conditional on this null hypothesis being true. If the null hypothesis isn't true, hopefully your results will show that, but you don't really know. We assume the null hypothesis is true all the way through. Here we calculate the standard deviation of p hat using the value of p we're hypothesizing is true. We calculate the z-score using the value we think is true. So your interpretation has to start off with that assumption that the null hypothesis is true. So until you get used to this, just try to copy this wording here, but replace the parts in the blanks here with the specifics from the situation following the model here.